Okay, today we're going to learn to find the area under a curve, and we're going to learn to do that visually. So, what if I asked you to find the area under a shape that looked a little something like this? If we go back to those lovely days of second and third grade, we remember that the area of a rectangle is length times width. Well, the length is between 1 and 4, so length is 3, the height is between 0 and 2, so 2, so the area of this lovely rectangle is 6. Unfortunately, life gets more complicated. Not everything is can be modeled with a straight line. So what if I asked you to find the area of this crazy shape? This is a curve, and one of the kind of key problems we face in calculus is how do we find the area under these shapes that aren't so nice and easy? Well, what we can actually do is use what we already know about rectangles, and so we don't know the area of this shape, but if we drew a rectangle inside of it, something like this, and we said, hey, the area of this little rectangle is 6, we know that the area of this red shape will have to be bigger than 6, or greater than 6. So we kind of have an estimate, right? Well, we can make that a little better if we take the area of an even bigger rectangle. So I'm going to say the area of this larger rectangle is, I don't know, let's say 12. So the area is underneath that, so the area is going to have to be less than 12. So this is kind of a neat way to begin approximating it, but we could actually push ourselves and make this a little better. So I'm going to erase this, and what we could do instead is, instead of having one small rectangle, let's push ourselves a little bit. Let's maybe put, I don't know, 2 or 3 little rectangles in here. And if you guys notice, I'm sorry, my drawing's not perfect. So I'm going to put another rectangle here, another rectangle here. And I know how to calculate the area of rectangles, so I could calculate the area of these 3 rectangles and say, area 1 plus area 2 plus area 3 is going to be less than, and I'm going to use, I don't know, let's use omega. It's my little Greek symbol. So the area of these 3 rectangles is going to be less than omega. I could then draw 3 larger rectangles that go above this graph and add and say, hey, omega is also going to be less than, and I should have drawn lowercase a's here, but we'll say the area of rectangles 4 plus 5 plus 6. Well, this is a pretty good approximation, but what we can actually do, and what actually one of the tools we build in calculus, is the ability to add lots and lots, and in fact infinitely many small rectangles underneath this curve, and then infinitely many larger rectangles. And by kind of squeezing the area of that shape in between those two, we end up with an exact answer, or numerical answer, for the area under a curve. So congratulations, my friend. In just a few minutes, you learned visually how to integrate the area under complex and weird shapes.